everyone, I'm Julia, an AV Foundation engineer. In this video, I'll discuss how to create an engaging user experience in your app across multiple players. People love to get multiple perspectives from live events like sporting competitions, or watch multiple channels simultaneously. A multi-view playback experience consists of playing multiple streams of audio and video at once. One use case is playing multiple different streams of the same event. For example, a soccer game with an audio stream for the announcer and 2 video streams with different perspectives of the field. In this case, it's important to synchronize playback between the streams. This way, important moments line up. Other examples of synchronized streams might include a music concert which has multiple camera angles, or a keynote speech that has both a main content stream along with a corresponding sign language stream. Another multi-view use case is playing multiple different streams of completely different events. For instance, showing streams of different events like track and field and swimming during the Olympics with some background music. In these cases, the audio and video streams do not have to be synchronized with each other. AV Foundation and AV Routing have API that makes it easier to build rich multi-view playback experiences. I'll go over these API in this video. I'll start with how to synchronize playback across multiple streams. Then discuss how to handle routing across multiple views for AirPlay. Finally, I'll share how to optimize playback quality across multiple players. When showing multiple streams that need to be coordinated, such as for a sports game, it's critical to synchronize playback across all the players so that important moments line up. This means that all playback behaviors, like play, pause, and seek, need to be coordinated. However, this can be a complicated process. In addition to rate changes and seeks, complex behaviors also need to be managed. The AV Playback Coordination Medium from the AV Foundation framework makes it easier to tightly synchronize playback across multiple players. It handles the coordination of rate changes and time jumps, as well as other complex behaviors like stalling, interruptions, and startup synchronization. I'll demonstrate how to use the AV Playback Coordination Medium to coordinate between multiple players in your app. In the demos I'll show throughout this video, I'll use the example of different camera angles of a train on tracks moving through different scenes, such as plants and other objects and landmarks. This train example helps to illustrate what multi-view content could look like with multiple camera angles. In the coordination demo, I'll be adding in multiple camera angles that were filmed from around the train track, just as if I were watching a sports game and wanted to add in different camera angles from a game. This is an iPad app with several different video streams of a toy train moving around the track. I start with a bird's eye view of the train track playing. I want to see more angles of the train, so I add in a side view of the track. The second stream matches up with the currently playing stream. I'll also add in 2 more camera angles recorded from around the track. Each additional stream will join in sync. If I pause, all players will pause in sync. Taking a closer look, I can see the train from multiple angles in all 4 players. In the top left bird's eye view, I notice the train is positioned near the top edge of the table by the plants. From the other camera angles, I can see that the train is beginning to enter the straight part of the tracks and is approaching the monkey from behind. Looking at the timestamp on each video, I can confirm that all are at the same time. Now I'll play, and all the players will begin playback in sync. I can watch the train in perfect coordination from the various angles. Next, I'll issue a seek forwards by 10 seconds. With each of these actions, the players remain in sync. Even if I leave my iPad app and switch to a picture-in-picture view, the streams remain synchronized. If I return to the app, all the videos are still playing in sync. This also works great across system interfaces, like with the Now Playing interface. Playback behaviors are also coordinated. I can pause and play, and the players remain in sync. Coordinating across all players creates a great user experience. In the demo, I've showed an example with a train moving through landmarks. In a real-world scenario, this could be sports events, sign language streams, or other multi-view use cases where you want to coordinate playback. Now that I've gone over what it looks like in action, I'll show how you can build this experience in your app. The AV Playback Coordination Medium API builds on the existing AV Playback Coordination architecture that exists for SharePlay. Each AV player has an AV Playback Coordinator that negotiates between the playback state of the player and all other connected players. To learn more details about the Playback Coordinator and how it works, check out the video, Coordinate Media Experiences with Group Activities. If there are multiple video players, the Playback Coordinator needs to handle remote state management and make sure that each player is in sync with the others. The AV Playback Coordination Medium communicates state changes across all playback coordinators. The coordination medium passes states from one coordinator to the other playback coordinators and keeps them all in sync. This is achieved through messaging. The coordination medium passes messages between players for important state changes, like playback rate, time, and other state changes. For instance, if one player pauses, it sends that message to the coordination medium. Then, the coordination medium will send this to all other connected playback coordinators. The playback coordinators will handle and apply the playback state. This way, all players are able to stay in sync when playing coordinated multi-view content. Implementing this only takes a few lines of code. I start by setting up my AV players, each with a different asset. Here, I'm using two videos, one for a close-up shot and one for a bird's eye shot. I'm configuring these separately with different assets. Next, I create the coordination medium. Then, I connect each player to the coordination medium by using the coordinate method. This method can throw errors, so it's important to handle them. Finally, I'll do the same for my second player, the bird's eye shot. Now, both playback coordinators are connected to the coordination medium, and the actions on each player will be synchronized. All I have to do is call an action on one player, and all of the other connected players will do the same. In this example, I only used 2 players, but you can connect more players. The AV Playback Coordination Medium is great for coordinating multi-view playback. Next, I'll talk about tools that can apply to any type of multi-view playback, both coordinated and non-coordinated. AirPlay enables an awesome external playback experience. People can route video streams to a larger screen in their home, or route an audio stream to a HomePod. It's important to route the right view to the right device. I'll go over how to support AirPlay in your app with multi-view experiences. Let's see that in action. In the example I'll show, I'm watching a bird's eye view video along with a track close-up video. Both videos are playing on my iPad. However, I want to AirPlay my video from my iPad to the Apple TV. The AirPlay receiver can only support a single stream, so if I route to it, I prefer the bird's eye view video to play on the big screen so I can see all the details more clearly. I begin playback of 2 videos on my iPad and route to an Apple TV. When I do so, the close-up view will continue to play on my iPad, and the bird's eye view video will be played on the big screen since it's my preferred player. If I want to change which video is playing on the TV, I can switch between streams by updating the preferred player to be the close-up stream, and the two videos will switch places. On this iPad app, this is done through pressing the star button, which will set the close-up video to be the preferred player. Now I select it, and the close-up stream will play on the TV while the bird's eye view plays on the iPad. Additionally, I can pause and play, and if the streams are coordinated, then they'll remain in sync. This is an example of a coordinated playback use case. However, uncoordinated multi-view streams also work seamlessly with AirPlay. The AV routing playback arbiter, which is part of the AV routing framework, enables you to easily integrate AirPlay support for multi-view experiences. The playback arbiter ensures that multi-view works smoothly with AirPlay or other external playback experiences that only support a single video or audio stream. It manages the complexities of switching to the correct audio or video stream. The AV routing playback arbiter is responsible for managing and applying preferences on non-mixable audio routes. These are audio routes where only a single audio stream can be played, and concurrent audio playback on the receiver is not possible. The playback arbiter also handles constrained external playback video routes. These are routes where only a single video stream can be played on the receiver, such as with AirPlay Video and Lightning Digital AV adapters. In a multi-view playback case, such as with the train multi-view videos, I might have a bird's eye view video and multiple close-up shots. I want the bird's eye view to take priority whenever I AirPlay video. First, I obtain the playback arbiter singleton. Next, set the bird's eye view as the preferred participant for external playback, a property on the playback arbiter. Now, if I route to an Apple TV from my iPad while playing multi-view content, the bird's eye view routes its video to the Apple TV, while the other videos continue to play locally on my iPad. Similarly, if there are multiple players and the bird's eye view should take audio priority, then first obtain the playback arbiter singleton and set the bird's eye player as the preferred participant for non-mixable audio routes. If multi-view content is playing, and I route audio to a HomePod from my iPad, the audio of the bird's eye view will be played. Next, I'll show an example of how to use this API. First, I set up two AV players, one of the close-up shot and one of a bird's eye view. Then, I obtain the playback arbiter singleton from an instance of the AV routing playback arbiter. I want to see the bird's eye video on the big screen whenever I route to AirPlay, so I set it as a preferred participant for external playback. And I want to hear its audio if I route to a HomePod, so I also set it as the preferred participant for non-mixable audio routes. In this example, I've chosen the same player for both properties, but this can be set to be different players. Through the AV routing playback arbiter, ensure a seamless integration of AirPlay and other external audio and video playback experiences in your multi-view app. Next, I'll tell you how to manage the quality of these streams. When watching multi-view content, some streams may be more important than other streams. For example, when watching a sports game in multi-view, one stream might be a bird's eye view of the field. Two other streams could be of different perspectives of the field, and another stream could be close-up views of the crowd. In this example, I care more about the bird's eye view of the field. I want to see it more clearly and have it play at a higher quality. I care less about the close-up views of the crowd, so I don't need to see it in detail and don't mind if it plays at a lower quality. In a multi-view scenario, different players may have different quality needs. Indicate this through setting the AV player's network resource priority. I'll discuss in detail how this works. When streaming content, each player consumes network bandwidth. If these players were equal-sized, you may want each to consume an equal amount of network bandwidth and play at the same quality. However, each player may have different network bandwidth and quality needs. To support this, set the network resource priority of the AV player. Each player starts with a default priority level. You can set the priority level to high or low. A priority level of high means that the player requires a high level of network resources, and streaming in high-quality resolution is crucial. A priority level of low means that the player requires minimal network bandwidth, and streaming in high-quality resolution is not as crucial. I'll walk through an example of how you might achieve this with a network resource priority. First, create an AV player, and then set the player's network resource priority. In the sports game example, the field bird's eye view is most important, so I set that priority to high. The crowd close-up view is less important, so I set it to low. As a result, the field bird's eye view will see a higher network priority, while the crowd close-up view will see a lower one. These network priorities are there to help indicate the priority of the player when the system allocates network bandwidth resources. The exact network bandwidth distribution takes a variety of other factors into consideration, such as number of other players, video layer size, hardware constraints, and more. Next, I'll show a demo of network priorities in action. In this example, I'll show the train multiview example, and this can extend to the sports game example and other multiview scenarios where different playback qualities are required. I'm watching two different streams, a bird's eye view of the train track and a close-up view of the train. It's important for me to watch the train without missing a moment, so I really want to see the bird's eye view clearly. I set the network resource priority of the bird's eye view to high. Both videos are currently playing in high resolution. The resolution tags are at the bottom of the videos. If I encounter poor network conditions and network bandwidth is limited, the close-up view on the right will switch down to a lower resolution first. I can see that happen now. The more important bird's eye view on the left will maintain a high-definition resolution. Through setting the network resource priority of a player, you could have greater control over the quality at which a stream plays. The AV Foundation and AV Routing API that I've discussed all work together to enable you to build seamless multi-view experiences. Now that you've seen these advanced multi-view features involving playback coordination, AirPlay integration, and quality optimization, build and enhance your own app with Multiview. Use the AV playback coordination medium to create compelling synchronized multi-view experiences. Synchronize multiple camera angles from your favorite sporting event. Explore the AV Routing Playback Arbiter to enhance a multi-view app with AirPlay integration. Take multi-stream playback, such as ASL streams, to the big screen. Fine-tune and optimize playback quality through network bandwidth allocation. Ensure important streams are playing in high quality. We look forward to all the exciting multi-view playback experiences you create. Thank you for watching.